In today's creative coding tutorial, we are going to learn how to make a game with JavaScript. We will practice front-end web development techniques by building a complete, polished Frogger game from scratch with no libraries. I will explain every line as we go along. You can use this on your website or in your portfolio. Hope it helps you to get the coding job you want. Hi coders, welcome to another episode of my creative coding series where we learn JavaScript by building games and interactive animations, all from scratch with no libraries. The skills and techniques I'm about to teach you today will help you to build your own unique games faster, but you can also apply them in any other JavaScript project. We are using pure vanilla JavaScript, so everything we learn here are transferable skills. I had a lot of fun building this one. I've hidden around 20 Easter eggs with references to famous movies and TV shows and some additional pop culture references on top of that. If you can spot some of them, let me know in the comments. Some are quite obvious, some are a bit more hidden. It could be on cars, hidden somewhere in grass, flying above or swimming underwater. Speaking of things swimming underwater, do you see the fish swimming right here? Do you know how to make a ripple effect like that with HTML canvas? If you know what technique I used to build this, leave a comment in the video description before you watch the video and you get a point. If you don't know, I will show you how to build this entire game from scratch right now. Hi, if this is the first time we're meeting, my name is Frank and I'm a self-taught front-end web developer. I worked in a supermarket and call center here in London while studying JavaScript in my free time. I've been through many interviews for a self-taught junior position until I got hired. If you want to talk about any of that and exchange our experiences, leave a comment. I will leave some links for Udemy courses that helped me a lot in my self-taught journey in the video description down below, so if you're interested, you can check it out. My goal with this series is to learn and practice vanilla JavaScript techniques while building fun projects from scratch with no libraries and no frameworks. We will build the base game skeleton quite fast, and then we will spend some time adding graphics, animating sprite sheets, and giving our game a polished professional look. If you followed my vanilla JavaScript series, everything we do today should be very familiar to you. But since it's around 20 videos full of creative coding tutorials, I assume most people who watch this video will not have watched all of that, so I will explain everything line by line as we code along today, as I always do. Today we are going to take things we have learned in this series so far and create a bigger polished game you can show off on your coding portfolio or personal website. You can also use this as a base for your unique game project. We will focus on collision detection, sprite animation, frame rate optimization, and keyboard input, but every technique we learn can be used for other web development projects as well, not just for games. Let's have a quick look at the game we are building today. It is a remake of classic 1981 Konami arcade game called Frogger. It received a popular sequel for PC and PlayStation 1 in 1997, and there are multiple clones like Go Chicken Go. As you can see, we have a frog starting down here on a rubbish-filled side lane. It needs to cross 3 lanes of traffic and river to escape to the forest. The main game loop is that every time you manage to get your frog across, you get 1 point. Game speed slightly increases, and another frog spawns down here, looking to escape from dirty side road to the nature. The game gets gradually faster. Let me know what's your high score you managed to get before the game became too hard. How many frogs did you save? Some of the graphical details I included this time. When frog hops over dry road, it leaves small clouds of dust behind. Moving over the river leaves water ripples. Yes, we will do some fun particle effects again today. We will add multiple layers of graphics, so grass here on the bottom and tree in the top right corner are placed over the frog, so you can hide there. We also have snails randomly hanging around here and here. What else? Butterflies are randomized as well. Game will load between 1 and 7 of them up here somewhere around the flower patch. This is a busy city, so we have planes, birds and other magical creatures flying overhead. You can see the shadows and there are things swimming underwater, so keep an eye out for that. I have around 30 randomized cars in my game, maybe more. I had a lot of fun hiding Easter eggs and movie references all around the place. I have recently discovered this channel with many game tutorials. Anna is a talented programmer and most importantly, she picks great projects for her videos. You might want to check it out and subscribe to her. Link in the video description. One thing I noticed is that she doesn't use Canvas, but she animates HTML elements, which is great to practice the DOM manipulation techniques and take advantage of built-in CSS transitions. On Canvas, we have to write more algorithms. Animations with Canvas have to be done more manually. There is no built-in ease-in transition, for example. Each approach has its pros and cons, and I think we should know both. I will use DOM manipulation to build this game with you soon. If you get value out of my content, hit the like button please, and consider subscribing. Let's start coding. We will work with 3 types of files as usual: index.html, style CSS, and I will separate JavaScript code into 6 separate files for clarity. You can also write all the code in one file as long as you keep it in the same order. I will use multiple canvas elements to create layers, all wrapped inside a div with a class of wrapper. I do this to easily organize our sprites in layers. We want dust particles to be under the frog. We want the frog to be under cars, but on top of logs and turtles and so on. There are other ways to layer sprites, but I think this is the easiest and the most intuitive way, so let's go with it. I will create, I guess 5 canvas elements. Not sure if I will even need the 5th one. Let's see how we get on. I will also link all the script files. Order of these files is very important here. The first one will be setup.js, which will contain canvas setup, global variables, and references to the sprites we use. Basically all the things that are needed all around our application. Frogger.js will contain code to create and handle player character. Particles.js will create dust trail under the frog when it's on dry land, and Ripples.js will create water ripples when we move over the river area. Obstacles.js will handle cars, logs, and turtles, and Utilities.js will contain all the other bits like animation loop and event listeners. In style CSS, I give wrapper a border 5 pixels solid black, and I center it exactly in the middle of the page, both vertically and horizontally, by using the absolute position centering trick: top 50%, left 50%, position absolute, width 600 pixels, height 600 pixels, transform translate -50%, -50%. I target all canvas elements and I set them to position absolute, background blue just to see what we're doing, top 0, left 0, width 100%, height 100%. And now I can remove the blue background again. For the wrapper, I set background to image, background PNG. You can download it in the video description. In setup.js, I target the first canvas with document getElementById canvas1, and I save it in a variable I call canvas. ctx1 will be equal to canvas getContext2d. Canvas width is 600, canvas height is 600 as well. I do this for all the other canvas elements. Let's declare our global variables. This is a grid-based game. One imaginary cell in our grid will be, let's say, 80 times 80 pixels. Keys will hold whatever key was pressed on keyboard. For now, I will set it to an empty array. Score will be 0 at first. We will also count collisions, just for fun. We will also count our frames, so we can add triggers and write statements like, for example, do something every 100 frames and so on. Game speed will increase slightly whenever we score a point. Let's start at speed 1. Particles array will hold all particle objects for dust effects. Max particles will limit how many we create to prevent performance issues. Let's set maximum to 300. Ripples array will hold water ripple particle objects. Cars array will contain our randomized cars. Logs array will contain turtles and logs, maybe even crocodiles. Basically the things that are floating in the river. In Frogger.js, I create JavaScript class. Constructor is a mandatory method every class needs to have. It runs only once when the object created by class is initialized, and its only job is to create a new blank object and assign it values and properties as declared here in the blueprint. So in the blueprint, I set this.width and this.height. Actually, I know I will be using sprite sheet for our frog character, so I might as well set it up now. Sprite width is width of one frame in our character sprite sheet. Our sprite sheet has two columns and is 500 pixels wide, so width of one frame will be 250. This.sprite height, sprite sheet is 1000 pixels high and it has 4 rows. 1000 divided by 4 is 250. This is quite big, so let's scale it down. I want our frog to be 5 times smaller. This.width is sprite width divided by 5, and this.height is sprite height divided by 5. I drew the frog myself. You can download it in the video description. If you're using your own sprite sheet, you can just calculate width and height of one frame like I just did. Our blueprint will also need x and y coordinates where the frog first appears on game load. Let's put it in the center of the page, at the bottom. This.moveIn will be false at first. This will prevent the frog from moving across the screen too fast when we hold down arrow keys. Each press will trigger only one jump to the next grid cell. This.frameX and this.frameY will as usual hold coordinates for current frame within the sprite sheet, and we will change these values dynamically to animate the frog. We will also need update method. Let's just put console log statement in there for now. And a draw method will draw sprites on canvas. Here I need to think about our layers. Canvas 1 will contain particle effects, Canvas 2 will have logs and turtles, Canvas 3 will have frog, Canvas 4 will have cars and any other overlays like grass at the bottom and tree in the top right corner. I'll show you when we get to it. So frog will be on Canvas 3, so CTX3 fill style is green. And for now, let's just draw a rectangle. I pass it x and y and width and height from Frogger class constructor. I will also create a variable called Frogger, and this will be equal to new Frogger. The new keyword calls its associated class constructor and makes the constructor create a new blank object and fill it with values as defined in Blueprint on lines 3 to 11. With this basic code in place, we can create animation loop. In the very last JavaScript file, I create a custom function and I call it, for example, animate. First, I will clear the canvas, CTX clear rect, and I pass it canvas dimensions to clear the whole thing between every animation frame. After it's clear, I want it to call draw method from Frogger object we have just created. Objects created by class constructor of course have access to all associated class methods. I will also call Frogger update. Now I run request animation frame built-in function and I pass it the name of its parent function, animate. This way, animate function will just run its code, and on the last line, it will just call itself again, create an animation loop, through programming principle called recursion, which simply means function calls itself over and over. I declared animate, so here on line 8 I also call it to kick off the animation loop. It doesn't work yet, let's see why. In setup.js I made a mistake. You can see I named all variables canvas. I need to rename them. We can't have multiple variables with the same name, so canvas 2, canvas 3, canvas 4 and canvas 5. Now we can see the frog, yes. It appears static, but it's actually drawing and clearing the canvas over and over inside the animation loop. To make it move, we will need event listeners. I create event listener for key down event and inside a callback function. If you remember on line 28 in setup.js file, we created an empty array called keys. This array will hold whatever key we press on keyboard. At first, I set keys to an empty array in case it holds some values from before. Now I do this weird thing when I say keys square brackets e.keycode equals true. Basically, I'm just adding whatever was pressed into the custom keys array. This entire keyboard input section will be very similar to what we did in the second episode of the series where we built a Star Wars game boilerplate. I will explain all of this again, but if you want more details, you can watch the video. Today, I will do this part a bit faster so we can focus on other fun features. So if we press 37 or 38 or 39 or 40, which are key codes for arrows on keyboard, we will call custom method on Frogger object called jump. This method will just animate the sprite sheet. I haven't declared it yet, so in Frogger.js, inside Frogger class constructor, I declare a new method called jump, and let's just put a console log in there for now. I can see that works great. Click the like please if you're getting value out of my tutorials. In update method, I say if key 38 was pressed, which is an up arrow key. Inside, I put another if statement, if moving is false. I will explain this in a second. Then, this.y minus equals grid. Grid is a custom variable we declared in setup.js. It is equal to 80 pixels, so Frog will jump 80 pixels up when we press up key. I will also set moving to true. In utilities.js, I create another event listener for key up. And here I just delete the key that was released from keys array. And I also set Frogger moving to false. So initially moving is false. When we press up arrow key, you can see I set moving to true on line 18, and this statement is only entered when moving is false as declared on line 16. So every time we press the key, Frog will jump up once. It will not keep moving when we hold the key down. It will only ever jump once every time we tap a key. Then, when we release the key, key up event will set moving to false as declared on line 20 in utilities.js. This will allow Frog to make the next jump whenever a key is pressed. I hope I'm explaining this right. Now I set another if statement for down arrow key. When key 40 is pressed and this.moving is false, and another if statement to prevent Frog to leave the screen only if this.y is less than canvas height minus this.height times 2. Actually, let's join these two if statements into one. I will check if this.moving is false here within the same statement. So only if these conditions are true, this.x plus equals grid. Grid is 80 pixels, so Frog will jump 80 pixels down. And I set this.moving to true to stop it from moving further if user holds down the key. Only when key up event occurs, this.moving will be set to false again and Frog can make another jump. Let's do the same thing for left key, key code 37. Also, I will merge these two if statements on line 22 into one. We are still checking for the same things, I'm just cleaning up the syntax. I will delete this bit. And I will copy this syntax. Now I change key to 37, which is left arrow. We will check if player hasn't gone past the left edge of canvas by saying this.x is less than this.width. If player x is within canvas area, and if moving is false, this.x minus equals grid, and this.moving is true. Same thing for right arrow key, code 39. This time we are walking to the right, so the plus direction on the horizontal x-axis. X plus equals grid. And we check if this.x is less than canvas width. Canvas width minus this.width. Nope, still too far. Canvas width minus this.width times 2. Great work, we have implemented keyboard controls. Now you can see I'm hopping around the canvas along invisible grid with cells 80 times 80 pixels. I will not put limits when player moves past the top edge because that's how you score a point when the frog escapes to the forest. You will see in a minute. Inside the custom update method on Frogger class, I create another if statement that says if this.y is less than 0. When player moves past the top edge of game area, we run function called scored. We haven't declared it yet, so in utilities.js I create a new function called scored. In setup.js we created variables called score and game speed. Every time scored function runs, we will increase score variable by 1 and game speed by 0.05. I will also reset the Frogger to its starting position, so Frogger X is canvas width divided by 2 minus this dot width divided by 2, which will center it in the middle horizontally, and Frogger Y is canvas height minus this dot height minus 40, which will position it 40 pixels from the bottom edge of canvas. We didn't reset Y. Oh, it's because I need to say Frogger width and Frogger height, since I'm referring to the Frogger object from the outside. I only use this keyword when I refer to it from inside of Frogger class. Now it resets when the scored function runs. What now? Let's create some obstacles. In obstacles.js, I create ES6 class called obstacle with capital O. Constructor will expect 6 attributes, x and y coordinates, width and height, movement speed, and type. You can see the syntax is slightly different than with Frogger class constructor. That is because we are passing all these values as attributes to the constructor from the outside. So all the constructor is doing here is assigning attributes we pass to it to properties on the new blank object it creates. I'm saying take x that was passed as attribute and assign it to x property on this new blank object we are creating right now. Obstacles will also have a custom draw method. Whenever I say custom, I mean it's not built-in JavaScript method, so you can name it whatever you want as long as you refer to it with that name when you call it later. So let's draw them on canvas 1 at first, CTX1. I will call fill rectangle and pass it x, y, width and height from constructor blueprint. Update method will just move obstacles horizontally, so this.x plus equals this.speed times game speed, because we want the game to speed up as the score increases, the slowly increased difficulty. We declared game speed on line 32 in setup.js, and it increases by 0.05 every time we score a point, as declared on line 25 in utilities.js. I cannot do plus game speed here, I need to do multiplication, multiplied times game speed, because this.speed can be positive or negative number, because some cars are moving to the right along the horizontal x-axis, which is in a positive direction, and some cars are moving left, which is in the negative direction. That's why we need to multiply times game speed to keep the same plus or minus value. If we just did plus game speed and current speed was -1, we would go from negative to positive numbers and all cars would eventually start moving to the right, which is not what we want. We want to keep the same direction, that's why we multiply here. I step out of obstacles class and I create a new custom function called initObstacles. Here we will go lane by lane and add new obstacle objects to our cars array and logs array. So for lane 1, I create a for loop that runs twice. We will add 2 cars to cars array. I call push built-in array method, which takes whatever we pass to it and pushes it to the end of the array. So I pass it new obstacle. New is a special keyword which calls class constructor on associated JavaScript class and creates a blank new object and assigns it values and properties as declared inside. In this case, on lines 2 to 8. We can see that on line 2, this constructor expects 6 attributes: x, y, width and height, speed and type. So when I call it, I need to pass it these values here. To handle horizontal spacing between individual cars, I create a temporary let variable called x, and I set it to I times 350. We are inside a for loop, so I stands for 0, then for 1, then for 2, as the for loop cycles. So each time we generate new car, its x value will be different. First, it's 0 times 350, which is 0. Then it's 1 times 350, which is 350, and so on. So each time this for loop runs, we push one new obstacle to cars array. It expects 6 attributes, so x will be this temporary x variable we just created. Y will be vertical position. We are placing cars on the first lane from the bottom, so y will be canvas height minus grid times 2. And I also have to do minus 20 because bottom margin is a bit larger to allow space for some nice roadside images later. Obstacle class constructor also expects width value, which will be size of the grid, 80 pixels, and height will be grid as well. Grid is a variable we declared in setup.js, and currently it is equal to 80 pixels. Speed will be +1, so we will be moving to the right, and type will be car. We will use type later when deciding what sprite to draw. So now I call init obstacles to fill array with obstacle objects for lane 1. I also have to create custom handle obstacles function, which will cycle through the entire cars array. So for loop here, and for each object in the cars array, I will call its associated update and draw methods as usual. This is actually all we need to do. In utilities.js, inside animation loop, I call handle obstacles. The sequence, how you call things here inside animation loop, is important for things that are on the same canvas element. I will call it after we draw and update Frogger. And we are animating 2 cars in lane 1. Let's make them different color with fill style blue. On line 23, the third value we pass to obstacle class constructor stands for width, as you can see on line 2. So if I want to make the cars wider, I can make the width this.grid times 2. That looks more like a car now. Also notice that cars drive past the right edge of canvas and never come back. So on line 16, inside custom update method, I say if this.x is more than canvas width plus this.width, meaning if the car has driven past the right edge of canvas and is completely hidden, now this.x is equal to 0 minus this.width, which will reset it behind the left edge. Like this. You can also play with these values. Look at what happens when I change speed here. Time to add more cars. Lane 2 will also have 2 cars, so for loop that does 2 cycles. Horizontal spacing between the cars will be 300 this time. Cars array push, and we pass it new obstacle, which expects 6 attributes again. X will be the temporary X variable from line 30. Y will be canvas height minus grid times 3 because we have moved 1 lane up, minus 20. Width is grid times 2. Height is grid. Speed is 2, type is car. We are moving to the right. Notice what happens when I pass negative value as speed. Cars start moving to the left, which is great, but the problem is that they don't reset anymore. I have to do the reset check a little bit differently. If this.speed is more than 0, which means for cars moving to the right, we use this code to check if the car disappeared over the right edge and resets it behind the left edge. Else, which means in this case speed is less than 0, so for cars moving to the left, if this.x is less than 0 minus this.width, if the car has moved past the left edge of the game area and completely disappeared behind the edge, we reset it by saying this.x equals canvas width. It will move it behind the right edge. Let's add this.width here to give the car small delay before it reappears again. Now we can go to init obstacles custom function and add lane 3. So again, I create a for loop that will run twice. Every time it runs, it pushes new obstacle object to cars array. Spacing between the cars will be 400 pixels, for example, and I pass it here as the initial x coordinate. Vertical y position will be canvas height minus grid times 4 minus 20. Width will be grid, height will be grid, speed is 2, and type is car. Okay, let's make it wider. Width will be grid times 2. If you want to add a bus or truck, you can also do grid times 3 here. So far, all 3 lanes had obstacles with a type of car. Lane 4 will be another for loop that runs twice and creates two obstacle objects. Horizontal spacing will be 400 pixels. We are now in the river area. So far we have pushed everything into cars array. Things that float in the river, which includes logs and turtles, will all go into logs array. So logs array, push, new obstacle, and since we are in the river, now vertical Y position will be canvas height minus grid times 5 minus 20. I always do minus 20 to make up for the slightly increased bottom edge. Width will be grid times 2, height will be grid, speed will be minus 2 because the river will be flowing to the left, and type of obstacle is log, which means piece of wood. I need to fix my syntax here. I add bracket and I pass a value for x coordinate we calculated on line 47. Now I go inside custom handle obstacles function, and same as I did for cars array, I will call update and draw for each element inside logs array. I need to do it like this in a separate for loop that cycles through the entire logs array. Lane 5 will be turtles we can hop on and they will give us a ride. Let's add 3 of them because they will be smaller, and we will push them into logs array. I want them to be closer together, so spacing will be 200 pixels. I pass our temporary x variable. Y position will be canvas height minus grid times 6 minus 20. Width will be grid, which is 80 pixels. Height will be grid as well, so we will have a square. Speed is 1 because turtles are slow, and type will be turtle. Here we go, we are making progress. Let's add another background layer. I will bring all these images into the project here in setup.js. As usual, when I want to bring a new image onto the canvas, I create a variable and I assign it to new image. Then I set its src property to a path to the image. This depends on how you organize your folders and project structure. In my case, background underscore level 2 src is equal to background underscore level 2.png. I will provide you with some sample images in the video description, or you can draw your own if you want. Now in utilities.js inside animation loop on canvas 1, so ctx1, I called built-in draw image method. It has 3 versions. We are just drawing an image that's the right size for our project, so I can use the shortest one, or the middle version actually. I will use the middle version, which takes 5 attributes: the image you want to draw, x and y coordinates, and width and height of the image. You can adjust and stretch the image by changing width and height values. I just wanted to cover the entire canvas, so width is canvas width and height is canvas height. The image variable was named background underscore level 2, and I need to remove quotation marks since it's a name of a variable, not a string. Now we have 2 layers. Water layer is all the way down on the bottom. This time I use CSS to draw it. And on top of that, on canvas 1, we have background level 2, which contains side lane, 3 lanes of traffic, and green riverbank on top. I separated the background images mostly because I want ripples, water ripples, to appear on water when frog jumps over it, but I don't want them to be spilling over the grass and road area. With background separated like this, I will be able to draw the ripples on top of river image, but under the road. I noticed that the green square representing our frog disappeared. I will just go back to animation loop and draw the background image before I draw the frog, so the frog will be drawn after, on top of it. Now the frog is back. Let's hide the obstacles for a while by commenting out handle obstacles in animation loop inside utilities.js file. Now I can see the road, so we can draw some dust particles. I will bring another image to the canvas. Ideally, all these images would be on a single sprite sheet, but I don't want to make this tutorial any longer by showing you how to do that in Photoshop. I will show you next time. So I create another variable called grass, and I set it equal to new image. This will be the top environmental layer. The image contains grass on the bottom and tree canopy with shadow in the top right corner. So I say grass src is path to the image, in my case grass png, because the image and this JavaScript file are both in the same folder. In utilities.js inside animation loop, I bring the image into the project again by using built-in drawImage method. This time we will draw it on canvas 4, so it's on top. And image variable is called grass, as we just declared in setup.js. You can see that frog is now under grass and under the tree, and even the shadow of the tree is cast on our frog when we are by the edge. Now to draw the dust particles when frog is hopping over dry road. In particles.js, I create JavaScript class called particle with a capital P. We will use this to build many similar particle data objects and push them into particles array, so we can use that information to draw them on canvas. Constructor will always run once for each particle at the point when it is called with the new keyword. It will hold blueprint information, and based on this, it will just create each randomized particle. This time, constructor will expect 2 arguments for x and y position. We need to pass that from the outside because we want x and y coordinates to always be under the frog as it moves around. So when we call it, we will pass it frog's current x and y from the outside. Then I just tell constructor x coordinate property on this object you are creating right now is equal to x that was passed as an argument. Same for this.y. This.radius, on the other hand, will be randomized internally here inside the constructor. Radius will determine size of particles. I want it to be a random number between 1 and 20. Particles will also slowly fade, so we will need opacity property. At first I set it to 1. I also want the particles to slowly spread from under the frog in random directions. To give them random direction of movement, I need to specify how I want them to move along horizontal and vertical axes. So direction x will determine random horizontal movement speed for each particle. It will be a random number between minus 0.5 and plus 0.5. Minus numbers will make particles go to the left, plus numbers will make them slowly drift to the right from their original position, which is under the frog. I do the same thing for vertical y-axis. Minus numbers will make particles move up, plus numbers will make the particles go down. I create another custom method I call draw. Its job will be just to take values for each particle and draw a circle there. Particles will be drawn under the frog, so let's try CTX3 and draw them on canvas 3. And for fill style, I use RGBA color declaration, where the last 4th value is for alpha, opacity. When you want to draw a circle on canvas, first you need to call begin path. Think of it as a pencil touching down on canvas to start the drawing. Built-in canvas arc method will draw a circular path based on angles we pass to it as arguments. So I pass it x and y coordinates, radius, start angle, and end angle. These specific values for start angle and end angle will draw a circle. I call CTX fill to fill the path with color, and I close path. Custom method I call, for example, update will run every frame, and it will move particles along x and y axis based on values in direction x and direction y variables. These can be positive or negative number as declared on lines 7 and 8, so particles will slowly drift in random directions away from the frog. I step outside particle class, and on the top level I create a custom function I call handle particles. Inside, I create a for loop that will cycle through the entire length of particles array. For each particle, we will call its update method to calculate current position for each frame of animation, and draw method to draw a circle there. At this point, particles array is still empty. I only want dust particles to appear when the frog jumps around, so outside the for loop, I create an if statement that checks if keys 37, 38, 39 or 40 were pressed. These are keyboard arrow keys. If any of these keys are pressed, it means the frog is moving. At the same time, I only want the dust particles to appear over the road, not when we hop over the river, so I also check if frogger y, vertical position, is more than 100. And for performance reasons, I don't want to have more than 200 dust particles in my particles array, so I check if length is less than 200. If all of these conditions are met, we enter the if statement and create a for loop that will run, let's say, 10 times. Each time it runs, we call unshift built-in array method on particles array. Unshift method takes whatever we pass to it in brackets as attributes and places that to the beginning of the array we call it on. So I pass new particle, the new keyword, which is a special command in JavaScript, and it will go to line 2 and run code inside particle class constructor. Constructor's job is to create one new blank object and assign it properties and values based on information we specified between lines 3 and 8. And this is how JavaScript ES6 classes work, that's all. You can now see on line 2 that our particle class constructor expects two arguments for x and y coordinate. So down here on line 32, I pass it Frogger x and Frogger y, because I want all the new dust particles to appear wherever the frog is jumping at the moment. To run this code, I go to utilities.js file and I add handleParticles function we just created inside the animation loop, so it will run for every frame of animation over and over. It kind of works. You can notice a couple of things. First of all, new particles appear in the top left corner of the frog, not in the middle. Also, once we reach 200 particles, new particles are not appearing anymore because we reached the limit. To fix that, I go to particles.js again, and inside handleParticles custom function, I create another if statement. I check if particles array length is more than max particles. Max particles is a variable I declared on line 35 in setup.js file, and it is currently set to 300. If particles array is more than 300 particles, we create a for loop that runs 30 times, and each time it runs, we call pop built-in array method on the array. Pop method just removes the last item from the array. So here I am saying if we have more than 300 particles, remove 30 particles in one go. For this to work, I also need to change condition on line 35, which currently adds new particles only if particles array is less than 200. I change it and I say only add new particles if particles array length is less than max particles plus 10. We want to have a little space there. You'll see why in a minute. I move this if statement back outside as it was before. It should work now. Yes. So now every time frog moves, we are adding 10 new particles on line 35, and if we have more than 300 particles, we are also removing 30 old ones on line 29. I want the particles to first appear exactly in the center under the frog. Their initial position is wherever frog is at the moment as we pass it to the new particles constructor. Frog takes up rectangle area, and rectangles on canvas are drawn from the top right corner, declared by x and y coordinates, going to the right down as declared by objects width and height. That's why I can adjust these values here on lines 3 and 4 by adding some value to x and y property to push the center point where particles spawn a little bit to the right and a little bit down. I also want particles to slowly become invisible. For that, I will use opacity property I declared on line 6. On line 11, where we set fill style color, for particles, I will just change RGBA color declaration slightly, and instead of having fixed opacity value here, I use string concatenation to add a dynamic variable from line 6 into the color declaration. Now it's dynamic and I can manipulate it with JavaScript. In update method, for every frame from each particle's first appearance, as long as its opacity is still more than 0.1, I will reduce its opacity by 0.9. I need to do this as an if statement because if I accidentally make opacity go to negative numbers, we will get an error and entire game will stop. These numbers will have to be tweaked. The way it is now, it just jumps straight from 1 to 0.1 immediately. That's wrong. I also want to reduce radius, so as long as the radius is more than 0.15, for every frame of animation, reduce the radius by 0.14. Same thing like with opacity, we need to make sure we never get negative number as radius, otherwise we will get an error. I can also see we are generating dust particles over water. I can calculate exactly at what vertical coordinate I want to stop drawing them, but I think it will work if I just change it like this. 100 to 250. Yes, it works. Only generate dust particles if frog's current position is more than 250 pixels from the top. I also want to create water ripples when we move over water. Inside handleParticles, I create another if statement Again, I check if any arrow keys were pressed, which means frog is moving, so key 37, 38, 39 or 40. At the same time, I only want to create ripples if frog is moving over the river, so Frogger Y is less than 250 pixels from the top. Inside the if statement, I create a for loop that will cycle 20 times, and we will call unshift this time on ripples array, which will store our water ripple particles. Unshift takes whatever we pass to it and places that in the beginning of the array. We call it on. So I pass it new particle, which we'll call particle class constructor on line 2. It expects 2 attributes. I want the ripples to start under the frog, so again I pass it Frogger X and Frogger Y as coordinates. I originally created ripples.js file, but now I'm thinking we will just do all of this here in particles.js. I will need the same functionality here we have for dust particles, so I copy for loop that cycles through the array and calls update and draw method. And I also copy the if statement that checks if we have more than 300 particles, and if so, it removes the old ones using array pop method. I change all references to particles array and replace them with ripples array. And I also change max particles, which we set to 300, and I replace it with number 20. We don't need that many ripples. So now, on line 48, for loop cycles through ripples array and calls our custom update and draw. On line 52, if we have more than 20 ripples, we remove 30 old ones. On line 58, we check if arrow keys are pressed, and if frog is over the river, and if so, we add 20 new ripples to the array. I might have to adjust these numbers later. I will see how it works out. I'm getting an error because here on line 60 I call new ripple, but it's actually new particle because that's what I called the JavaScript class here on line 1. Now it works. We of course don't want water ripples to appear the same and have the same behavior like dust, so I will have to create another custom method on particle class called ripple, which will replace update method. I want the water ripples to start small and grow until they reach certain size. If this.radius is less than 50, this.radius plus equals 0.5. If I do that, the circle will grow just to the one side. I want it to grow from the center, so I also have to be pushing it slightly to the left and up by saying this.y minus equals 0.1, this.x minus equals 0.1. And as I said in the beginning, some animations and transitions you get built in with CSS. You actually have to build manually with Canvas. Maybe there's a better way to do this. I can't think of it now, but this will work. Another if statement where we check if opacity is more than 0. We decrease it by a very small amount, so our white ripples slowly disappear. On line 58, instead of calling update method, which handles dust particles, I call ripple method we have just created. We are getting there. We are still using the same draw method we used to draw dust to draw water ripples. That's why you see circles filled with gray color. I will have to create a different version of this method, so new custom class method called draw ripples. Let's change RGBA color declaration to white. Now I go down to line 67, and instead of draw method we use to draw dust, I will call draw ripple. It is fill in circles, but I actually only want to stroke it. So on line 31 I change fill to stroke, and on line 28 I change fill style to stroke style. I will go to utilities.js and move handle particles after Frogger draw, so we see the ripples on top of the frog and I can center it better. Back in particles.js, I change CTX3 to CTX1. It doesn't place particles back under the frog, which is drawn on Canvas 3, so now I know there is an error somewhere with Canvas layers and how they are stacked on top of each other. I will find it, but for now let's just make sure the ripple circles are centered. I will change values here on lines 37 and 38. Get in there. How about these values? Let's use even smaller numbers. It's starting to look alright. On line 70, I reduce the number of ripples we remove down to 5, maybe even less. On line 41, I increase how fast we reduce opacity to make the ripples disappear faster. I kinda like these values. Of course, I don't want ripples on the riverbank, so on line 75, where I check if Frogger's current position is less than 250, I also check if it is more than 120 maybe? No. 100 will work. Yay, we have ripples as we jump over water. You can see the ripples spill over the riverbank and road, even though I draw them on canvas 1, which should be at the bottom of our canvas stack, under the road image. So where is the bug? If I go to animation loop and I draw background level 2 after handle particles, water ripples work well, but the dust particles disappear, so I assume they are now drawn under the road image. Our layers don't stack properly. I will find the bug eventually, let's just continue. I will clear all 5 canvases between every frame of animation. This is not necessary for parts of the game that don't need to be redrawn when they don't animate. I will show you some optimization techniques for this later. On line 42, in Particles.js file, I slightly increase this number to make ripples disappear faster. Just for clarity, I'm going to separate handle particles into 2 functions. Handle particles will take care of dust, and handle ripples will contain code that manages water ripples animation. In Utilities.js inside animation loop, I will call handle ripples, which are drawn on canvas 1. Then I draw background level 2 image, which contains road and riverbank. And then I call handle particles to draw dust on canvas 3. If I do this, the layers stack properly, but reorganize in order in which you draw things here in animate function should only be necessary if you draw everything on the same canvas, which we don't. We have 5 canvas elements, so order here should be irrelevant. It is not irrelevant, so it means I made a small mistake in setup.js and I am drawing everything on canvas 1 somehow. In Utilities.js on line 14, I uncomment handle obstacles to make cars, logs, and turtles visible again. Sorry, my screen recorder froze, so I have uncommented line 14 in Utilities.js and obstacles are now visible. In Setup.js on lines 2, 7, 12, 17, and 22, I am assigning all context to the same canvas variable declared on line 1. I can't do that. I need to assign context to each individual canvas like this. Now we fixed our strange stacking issue. Everything works, yay! I will draw obstacles on canvas 3, so it is visible over the road image. I'm drawing on canvas 2. Time to start counting score. In Utilities.js, I create a custom function called handle scoreboard. It will be on the top layer, so canvas 4. CTX4 fill style will be black and font, let's say 15 pixels Verdana. I will try stroke text and I want to outline word score at coordinates 265 and 15, which should be roughly in the center. So I will also declare stroke style and I set it to black. Now all I have to do to draw it is to call handle scoreboard inside animation loop up here. For the actual score number, I will change font to 60 pixels Verdana, and this time I will call fill text. I want the text to take value from score variable we declared on line 29 in setup.js, and x and y coordinate will be maybe 270 from the left on the x-axis and 65 from the top on the y-axis. Now I make the font smaller again, 15 pixels Verdana, and I will stroke text that says collisions, and I concatenate value from collisions count variable at coordinates 10 and 175. This will show how many times we were hit by a car or fell into deep water. It's a bit strange that Frog in this game can't swim, but I didn't make the rules. I will also display current game speed using game speed variable we declared in setup.js, and I draw this text at coordinates 10 and 195. In Frogger.js on line 38, there is this small if statement that says if this.y is less than 0, meaning if frog jumps past the top edge of game canvas, run custom function I called score. That function is declared here on line 34 in utilities.js, and every time it runs, it increases score by 1, increases game speed slightly, and resets Frogger to the starting x and y coordinates. We can see it works, but game speed is giving us a very long number. I can change that by calling toFixed built-in JavaScript method, and I pass it 1. Doing this, game speed will only show one number after the decimal point, like this. Much better. Every time game speed variable increases, it increases movement speed of cars, floating logs, and swimming turtles, because we are multiplying their x horizontal position by game speed inside obstacles.js on line 15. I can test if it works by manually changing value in game speed variable on line 32 in the setup.js file. Right, now we can just jump through cars and nothing happens. Let's set up collision detection. Everything is a rectangle, so today we will do collision detection between two rectangles. I will make it into a reusable function. A little bit of functional programming can be good since we do so much object-oriented programming with all these classes and particles. So the idea is that we have a reusable function that takes two arguments, first and second. So for example, Frogger will be first and car1 in obstacles array will be second. Then we will just run this for the entire cars array and we check if Frogger collides with any of the cars. I want the function just to return true or false, and since we are checking collision between two squares, I can do this thing where I first check for scenarios where I know for sure that these two rectangles don't collide, and I return opposite of that by using exclamation mark. Let's just write this out first. It's much easier than it sounds. I will explain it once we write it. If first.x is more than second.x plus second.width, I note that the rectangles are far enough on the horizontal x-axis and I know for sure they don't collide. That's all I need to check. If this condition is true, I already know there is no collision, so I don't even need to check the rest. Also, when first.x plus first.width is less than second.x, I also know they don't collide and I don't need to check anything else. Or when first.y is more than second.y plus second height, also there can never be collision. Or when first.y plus first.height is less than second.y. If any one of these four statements is true, our collision function will be true, but I am using exclamation mark on line 55 to turn it into false, because OR operator will just return true if any one of the statements involved are true. If any one of these statements are true, it means there is no collision, so we want our collision function to return false. That's why I'm using exclamation mark to return the opposite. On the other hand, if all of these four checks return false, it means the two rectangles are overlapping. The function will want to return false, but I am converting it to true by using exclamation mark, so collision will return true. Sorry, double negative sometimes takes a bit of concentration to realize what's going on, so let me say the same thing again using different words. If any single one of these four statements is true, we know for sure the rectangles are not overlapping. OR operator will return true, and we turn it to false with exclamation mark because they are not overlapping, so we want collision to return false. On the other hand, if all of these four checks are false, we know implicitly that these two rectangles must overlap, because otherwise one of these statements would be true if they were not overlapping. If all four are false, we know we do have a collision. The statement wants to return false, but I convert it to true using exclamation mark, and our collision function returns true. This is a really great way to do reusable collision detection. If you get this, you will become a really efficient game developer. Maybe you want to rewatch the last minute of the video, it helps to hear it again. For this to work as a reusable function, the objects you compare as first and second need to have x, y, width and height properties associated with them, so keep that in mind. Obstacles and Frogger have these attributes, as you can check in their constructor methods. I can now use the collision function we declared. I need to run it for every frame of animation, so for example here in obstacles.js inside handle obstacles, I check for collision with cars by creating a for loop that cycles through the entire cars array, and I say if collision between Frogger and cars1 cars 2, cars 3 as the for loop goes. If the collision returns true, we will draw collision image. I have it on sprite sheet, so I will need to use the longest version of draw image method. I had an entire episode about this, but I will explain it again right now a bit faster. The first attribute is the image you want to draw. I haven't declared it yet, but I will call it collisions. The next 4 attributes are area from the source image you want to crop out, so source X, source Y, source width, and source height. I know my sprite sheet is 100 times 100, so the image is second from the top, so X is 0, Y is 100, width is 100, height is 100. And the last 4 attributes are where on canvas you want to draw that cropped out image. I want it drawn wherever the frog is at the moment when it collides, so Frogger X, Frogger Y, and I scale it down to the size of 50 times 50 pixels for width and height. So if collision between Frogger and car occurs, draw the second image from collision sprite sheet where the frog is right now. And then we call custom reset function, which will reset our game. I need to bring that image into the project, so in setup.js I create a variable I call collisions and I set it equal to new image. Collisions src is collision png. You can get sample image in video description or you can draw your own. Now I refresh the game. In utilities.js I create a custom function called reset game. When frog gets hit by a car or falls into deep water, I want to reset its x and y to the starting position. I can just copy that from scored function. I will also reset score back to 0, increase collision count variable by 1, and return game speed back to 1. Now when frog gets hit by a car, collision image quickly flashes before the frog gets reset. You can also see I have another image we can use when frog falls into deep water. It's time to replace the blue rectangles that represent cars, logs and turtles with images and animated sprites. I will use sprites for turtles because they move their flippers as they swim. Logs and cars will be static images, but you can use the same technique and add animations to them as well if you want. In obstacles.js on line 11, inside custom draw method, I say if this.type triple equals turtle, we pass this.type as the last attribute to our obstacle class constructor. It's either a car, log, or turtle. This is what we need that property for, to differentiate between cars, logs, and turtles. I could have also just do something like 1, 2, 3, but this is easier to read and understand. If this.type is turtle, on canvas 1 we call draw image. In setup.js I will bring new sprite sheet into the project, const turtle equals new image. Turtle src is turtle png. It will be a simple sprite sheet with 2 animation frames and 4 different colors for turtles. While we are here, I can also bring the log image here and cars as well. Ideally, all this would be in a single sprite sheet. I will show you how to merge images and map sprite sheets in some later episode. I will also create a variable called number of cars and I set it to the number of rows we have in the car sprite sheet. We will use this to randomize what car appears when they reset, when they move past the edge and come again. Back to obstacles.js on line 12, I want to draw an animate turtle from the sprite sheet. Again, the longest version of draw image built-in method. It takes 9 attributes, image you want to draw, 4 attributes for the area you want to crop out from the source sprite sheet, and another 4 attributes to specify where on destination canvas you want to draw that cropped out image onto. I will also call fill rectangles so we can see if hitbox area matches the image to make sure when we jump on the turtle we don't fall into the water. I will call fill rectangle before I call draw image, so it will be under the turtle image. I can see the turtle sprite sheet I'm using is 140 pixels wide with 2 columns, 140 divided by 2 is 70, and height is 280 pixels with 4 rows. 280 divided by 4 is also 70, so one frame is 70 times 70 pixels. So in draw method, I crop out rectangular area from the source sprite sheet at 0, 0 coordinates going to 70, 70. This will crop out one frame, the one frame from the top left corner. The last 4 attributes are where on the destination canvas I want to draw that cropped out frame onto, so I just want to draw it wherever the turtle is swimming at the moment, so this.x, this.y, this.width and this.height. I comment out lines 15 and 16 to only show turtles. We are still not drawing them. In setup.js on line 51, the name of Turtles sprite sheet is actually turtles.png and I misspelled src. Yes. In obstacles class constructor, I will add 2 more properties that will help us to navigate within the sprite sheet as usual. This.frameX will be x coordinate of cropped out frame. Frame y will be vertical y coordinate. On line 15 inside drawImage method, instead of hardcoding coordinates 0, 0, which always give us top left image, I will set x coordinate to this.frame times 70 and y coordinate to be this.frame times 70. If this.frameX is more than 1, set it back to 0. We will just cycle between frame 1 and 0 horizontally. Else, this.frameX plus plus. Now our turtles are animated, but you can see they all move at the same time, which looks very robotic. To desynchronize them, I can create another variable called randomize, and I set it to random number between 30 and 60. And I use math.floor because I don't want decimal points. In setup.js on line 31, we have a variable called frame. So in utilities.js, I go inside animation loop and I increase frame variable by 1 every time the loop runs. Now I can use this in obstacles.js. On line 15, I say if frame modulus 10 is 0, only then increase frame x. Modulus operator gives you remainder. So for example, if frame is 12, then frame modulus 10 will be 2, because 12 divided by 10 is 1, and 2 is the remainder. Basically, I'm saying do this every 10 frames. Actually, this code needs to be outside the if statement. I can remove the black rectangle now. Now the turtle frames animate every 10 frames. Here on line 10, we have our randomized variable, which is a random number between 30 and 60. On line 15, I replace 10 with this.randomize, and now each turtle will move its flippers at different pace. On line 20, I say else if this.type is log. This time we have just a single log image, so I can just use shorter version of drawImage method. The first attribute is image we want to draw, so log, as we declared it on line 54 in setup.js file. And the next 4 attributes are just x, y, width, and height. So I take that from the obstacle object. That was easy. Now we draw the cars. I say else, meaning if type is the last remaining option, which is car, I call drawImage, built-in method again. Car variable is the image we want to draw as we declared in setup.js. It will not animate, but we want to pick up random car from a big sprite sheet full of cars. So same as we did for turtles, I will use the longest version of drawImage method. Let's just crop out 1 frame at first to see how it works. X and Y is 0, 0. Width is grid times 2 and height is grid. These values depend on what size is your sprite sheet you are using. My sprite sheet is exactly the right size we need, so I didn't have to calculate frame size here. The next 4 values determine where you want to draw it, so that's this.x, this.y, this.width, and this.height. Nice. I want to pick a random car from the sprite sheet, so I create a new variable called carType, and it will be a random number between 0 and number of cars variable we declared in setup.js on line 58. This will be the number of rows in our sprite sheet, so in this case I put number 3 because the first row is 0, so 0, 1, 2. Actually, I will put down number 3 because we will use math.floor, which will round it down. In obstacles.js on line 24, I leave x as 0 and y coordinate will be this.carType, which is at the moment a random whole integer between 0 and 2, times this.height. Height of the grid is 80, so y coordinate will be 0 or 80 or 160. Now we are cropping out random cars. You can see that the middle lane of cars is going backwards. That's why I need the second column in my sprite sheet for cars facing the other way. On line 31, where we check if this.speed is more than 0, I also set this.frame to 1. Then on line 24, I can say that x coordinate we crop out from the source sprite sheet will be this.framex times this.width. Now we have all the cars going backwards. I actually need to set this.frame to 1 for cars with speed less than 0. Those are the cars moving left along the horizontal x-axis. That's it, nice. On line 32, we check if obstacles move past the right edge of canvas. I will also randomize car type, so every time car moves off screen, it will randomly pick different car from the sprite sheet before it appears again. I do the same for cars that move past the left edge by adding the same line of code to line 40. You can add more cars to your sprite sheet. I might show you how to do that in Photoshop a bit later. On line 24, I will draw a black rectangle under the cars just to check the collision area. It needs to match the image of the car as closely as possible. We don't want the frog to be hid by invisible margin around the car. I think this is good. We are moving on the grid, so it will work. I also need to write code for collision with logs and turtles. It will work differently because we need to jump on the log to get across the river. First, I check if the frog is in the river area. We don't need to run collision detection with logs and turtles if we know Frogger is not moving over the water. So only if Frogger Y is less than 250 and more than 100, I go to setup.js, and on line 33 I declare a global variable called safe, and I initially set it to false. Frog will be only safe if it's colliding with log or turtle, otherwise we assume it fell into deep water. Back in obstacles.js, I set safe to false in case it was set to true somewhere else. Then I run a for loop that will cycle through the entire logs array, which holds our logs and turtle objects. For every element in the array, same as we did for cars, I will run custom collision detection function we wrote earlier. We want the frog to be able to ride on floating objects, to be attached to them. I say if frog collides with any log or turtle, start adding speed of that particular log it's colliding with to frog's current horizontal x position. Small mistake on line 92, I run this code when Frogger Y is less than 250. Yes, now we can ride around on logs and turtles. I also set safe to true. To make sure the game resets when we fall in deep water, I say if safe is false, call custom reset function we wrote earlier. Also, I feel there should be water ripple animation when we sink, so I just create a for loop that will add, let's say, 30 ripples. I do the same thing we did before by calling unshift on ripples array, a new particle, and I pass it Frogger X and Frogger Y coordinates to tell it where I want to draw it. That works, well done. What happens if I sit on the log too long and it takes me off screen? Okay, good, the game resets as well, that's perfect. Let's replace the green square with frog from a sprite sheet. In Frogger.js, down on line 41, inside custom draw method, I call draw image and I pass it Frogger. I haven't declared that yet, so in setup.js, I bring Frogger sprite sheet image into our project. Const Frogger sprite is new image. I can't just call it Frogger because I use that variable name for Frogger data object already. Frogger sprite src is equal to Frogger png. In Frogger.js on line 44 I pass 0, 0 and xy coordinates for frame we want to crop out from the source sprite sheet. We also have sprite width and sprite height variables we declared before, so I use these here for width and height. In setup.js on line 62 I need to make sure the path and name of my sprite sheet is correct. I actually named it frog_sprite_sheet. And in Frogger.js, inside drawImage method, I need to replace Frogger with Frogger sprite, because that's how I named my image variable. We are drawing something in the top left corner of canvas. I need to add 4 more properties and use the longest version of drawImage method so that JavaScript understands I want to crop out one frame only. The longest version of drawImage method takes 9 attributes. Image you want to draw is the first one, then the next 4 specify what area you want to crop out from the source sprite sheet, and the last 4 are where you want to place that cropped out image on canvas. I just want to place it at wherever the frog is at the moment, so this.x, this.y, this.width and this.height. It's very small, so we can scale the sprite sheet by changing the last 2 values. If I say this.width times 2, it will stretch it horizontally. But if I also say this.height times 2, I successfully scaled it. You have to be careful when you do this, because scaling the sprite usually moves it outside its collision detection area. In games, this is also called the hitbox. I uncomment line 43, so we can see the green rectangle which represents the object we run collision detection for. So we need to make sure frog image is aligned over that area as closely as possible. I will move it 25 pixels to the left horizontally by saying this.x minus 25 and also vertically this.y minus 25. Now it's aligned. I just want to make the frame dynamic dependent on frog movement, so instead of hard coding x and y coordinates we crop out from the source image to 0, 0, I change x coordinate we crop out to this.framex times this.spritewidth. I also change y cropping coordinate to this.framey times this.spriteheight. Now up here in update method where we check if key 38, which is an up arrow key, was pressed, I want frame x to be 1, which is the image of frog jumping up. Frame y will be 0 to give us the first row. On line 47 inside custom jump method, I say if this.movin is false, this.framex equals 1. Else if this.framex is 1, this.framex is 0. I just want the jump animation frame to quickly flash. I'm not happy with this. Let's see. In update method, if down arrow key is pressed, I set this.framey to 3 because that's the bottom row in the sprite sheet and we count from 0. Left movement will have this.framey equal to 2 and right movement will show the second row, so number 1, because we start counting from 0. Because image is cropped out from the top left corner of cropping area. Now we can move in all directions and the frog is correctly facing that way. I can remove the green rectangle under the frog by removing fill rectangle from draw method on line 46. Also in obstacles.js I can remove black rectangle from under the cars by removing fill rectangle call on line 24. This is a long video, let me just hack it. In utilities.js on line 33, whenever key up event fires, I will set Frogger FrameX to 0. And it works. There is of course much better way to do this. I might release a second part where we optimize this code, add more graphical effects, Easter eggs and maybe some more game mechanics. If you want a challenge, you can try and draw a shadow under the frog when it hops over road and the riverbank. Or you can take an image of star or crown and draw it on frog's head when it reaches score over 20. You can also add water jets on turtles, because at that point they will be moving quite fast. Little hint on how to do this is just to go to draw method where we draw frog or turtle, and right after draw image you place an if statement that checks what the current score is. If the score is over 20, it draws a particular image on top of frog or turtle at their specific coordinates. So you pass it this.x, this.y. You might have to adjust the size and coordinates slightly for it to look good and fit well with the underlying image, like we did when adjusting frog hitbox area. We can also introduce other features like random shadow flying overhead you have to hide from, dangerous creatures swimming underwater. We can add more cars, different skins for our frog, and so on. If you want me to show you how to do all of this, let me know and I will do a part 2. Also, if you did code along, well done, this was a long video. Let me know in the comments if you finished the tutorial. I'm not sure if this is too long or if some of you like more complex, fun projects like this. Did you try to add any additional features to the game? What other projects are you working on? Anything interesting? Let's discuss all of that in the comment section down below. Click the like please. See you next time.